JEE Main 2026, 2Apr-shift-2, Physics Section A, Question 40. Let's visualize the setup. We have 2 point charges on the x-axis. A positive 8 microcoulomb charge is at x equals 2 centimeters, and a negative 2 microcoulomb charge is at x equals 4 centimeters. Now, we draw 2 spheres centered at the origin. The smaller sphere has radius 3 centimeters. Notice that the 8 microcoulomb charge at x equals 2 is inside this sphere since 2 is less than 3, but the minus 2 microcoulomb charge at x equals 4 is outside since 4 is greater than 3. The larger sphere has radius 5 centimeters. Both charges are inside this sphere since both 2 and 4 are less than 5. The question states, 2 point charges 8 microcoulomb and minus 2 microcoulomb are located at x equals 2 centimeters and x equals 4 centimeters respectively on the x-axis. The ratio of electric flux through 2 spheres of radii 3 centimeters and 5 centimeters with centers at origin is blank. The options are A, 4:1, B, 3:4, C, 4:3, D, 4:5. The key concept is Gauss's law. It states that the total electric flux through any closed surface equals the enclosed charge divided by epsilon naught. Here we see a Gaussian surface enclosing a positive charge. The flux lines point outward through the surface. The crucial insight is, the flux depends only on the charge enclosed within the surface. Charges outside the surface contribute zero net flux. This is extremely powerful for our problem. Step 1. Let's find the flux through the sphere of radius 3 centimeters. This sphere is centered at the origin. The 8 microcoulomb charge is at x equals 2, which is inside this sphere since 2 is less than 3. The minus 2 microcoulomb charge is at x equals 4, which is outside since 4 is greater than 3. By Gauss's law, only the enclosed charge matters. So the enclosed charge is 8 microcoulomb, and the flux Phi1 equals 8 microcoulomb divided by epsilon naught. Step 2. Now the sphere of radius 5 centimeters. The 8 microcoulomb charge at x equals 2 is inside since 2 is less than 5. The minus 2 microcoulomb charge at x equals 4 is also inside since 4 is less than 5. So the total enclosed charge is 8 plus minus 2, which equals 6 microcoulomb. The flux Phi2 equals 6 microcoulomb divided by epsilon naught. Step 3. Now we take the ratio. Phi1 over Phi2 equals Q enclosed 1 over Q enclosed 2, since epsilon naught cancels out. This gives us 8 microcoulomb over 6 microcoulomb. Simplifying, 8 over 6 equals 4 over 3. Therefore, the ratio of electric flux is 4:3. Let's check the options. Option A says 4:1. That would mean the second sphere encloses only 2 microcoulomb, which is incorrect. Option B says 3:4, which doesn't match our ratio at all. Option D says 4:5, also incorrect. Option C says 4:3, which matches our calculation of 8 over 6 perfectly. The correct answer is option C, 4:3. Here are some exam tips for Gauss's law problems. Remember, flux equals Q enclosed over epsilon naught. The flux depends only on enclosed charge. What matters is charges inside the surface. Charges outside and the size or shape of the surface do not affect the flux. Tip 1. For ratio problems, simply compare the enclosed charges. Epsilon naught cancels out, so there's no need to compute the actual flux values. Tip 2. Always check which charges lie inside each Gaussian surface by comparing the charges distance from the center with the sphere's radius. Like and subscribe for more JEE Main solutions at MAGPIEHUB.